Welcome back, polar bears and polar cubs. Let's talk about molecular geometry. Well, let's do a little bit of review first. And the first thing I want to review is that ionic bonds occur between a metal and a nonmetal, first and foremost. Then you're going to look at if it's covalent, it is nonmetal plus a nonmetal. It is only after you've determined if it's ionic or covalent, then you're going to do the electronegativity subtraction to determine if it is nonpolar covalent, which we put as NPC, or polar covalent, which we put as PC. As a reminder, here are the ranges. As soon as you know it's a metal and a nonmetal, it's ionic. Just stop there. You don't even have to do the electronegativity difference. Now, order written. So when it comes to the order written, it's usually left, if it's covalent, it's the one that's furthest to the left is the central atom. And ionic, the central atom is the cation. So why is this important? Well, this is important so when we're doing our drawing, we know who needs to be in the center to be bonded to everyone. It is more important here when it comes to covalent than it is on ionic, where you really just have to play around and try to keep the charges from being the same next to each other. Okay. When it comes to metal and nonmetal, PC is still ionic. So what does that mean? It means that if the ionic difference is ionic, so if it reads polar covalent, okay, it's still ionic because of a metal plus a nonmetal being ionic. So position on the periodic table trumps electronegativity difference. The same can be said for two nonmetals. If their electronegativity difference is I, meaning ionic, it's still polar covalent because it's two nonmetals. And then the big one that you might want to remember is that beryllium acts covalently. So when we add up total number of valence electrons, this is column number 3. So everything that we've talked about so far has been column number 2, that's determining bond type. For column number 3, you're determining number of valence electrons. So a little add-on is if you have a negative ion, meaning it has a negative charge, you add that number of electrons. If it's positive, you subtract that number of electrons. So for example, with magnesium and chloride, you have 2 valence electrons from magnesium. You then have 7 valence electrons from each chlorine, giving us a grand total of 7 plus 7 plus 2, 16 valence electrons. So you would just write 16 in column number 3 if you had MgCl2. When it comes to CO3 minus 2, you're going to do the same thing. It is 4 valence electrons. Now, oxygen has 6, so 6 times 3 is 18. And then since it's a minus 2 charge, we're going to add 2 more valence electrons. So when you add this up, you got 4 plus 18, which is 22, plus 2 is 24. Moving into the last example that we have here, you have N, which has 5 valence electrons. Each hydrogen has 1, giving us 4. Now, since it's a plus charge, it's actually minus 1 valence electron. If you take away a negative, you become positive. So what this ends up being is 5 plus 4 minus 1. So 9 minus 1 gives us 8 valence electrons. And that's how you determine what goes in column number 3. So once you've determined the central atom, how do we draw it? So remember that hydrogens or halogens are not the central pair. They only get bonded once. When they have more of one element than others, those are usually surrounding the central atom. So for example, SO3 minus 2. So we need to add up the valence electrons real quick. S has 6, so does oxygen. So 6 times 4 gives you 24 plus 2 for the charge, giving us a grand total of 26. So how we're going to draw this is we're going to put the S in the middle. We're going to attach an oxygen on either side until we run out. And then we're going to make sure that everybody has 8. So oxygen needs 6 more here. Sulfur needs 2 more. Each oxygen then also needs 6 more. So let's count them. So it should equal 26. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So what I did was 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I have the correct number of valence electrons shown in my drawing. It must be correct. I'm going to put in charges or brackets to signify that it has a charge. So let's go ahead and try our next example. Remember, this was 5 plus 4 minus 1, giving us a grand total of 8 valence electrons. So we're going to go ahead and put nitrogen in the middle. We're going to bond each of the hydrogens. And we're going to count. So by counting, we're going 2, 4, 6, 8. Everybody's happy because hydrogen only needs 2. And we're going to put in brackets then and put a +1 charge. So it's not too difficult when we're dealing with ones that maybe don't need a double or triple bond. So this is what we just did. We arranged the rest of the atoms around the central atom. If it is covalently bonded, we place a dash between every atom. So that's what we did. And then you're going to put single pair of valence electrons until you reach 8 for the ones that need to have it. So the exceptions, again, are hydrogen. Hydrogen, when it's happy or completely content, should look like that. Beryllium, remember, it is an exception because it's a metal, but it bonds covalently. And then boron only wants to have 6, so it should have 3 dashes coming off it to be happy. So what happens is if we run out of electrons, aka we went over, we have to begin to make double and triple bonds. So what happens here? You have 5 plus 18 plus 1, giving us a grand total of 24. So we're going to put N in the middle. We'll attach 1 oxygen on all 3 sides. And then we'll make sure that everybody's happy with the octet rule. So now everybody's happy. We're going to count. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Well, we have 2 too many. So what we're going to do is we're actually going to erase 2 from the nitrogen. And we're going to erase 2 from one of the oxygens. I'm going to choose that one. Now, by erasing those 2, I now need to make a double bond here to make sure that everybody has 8. We're going to count again 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We have 24. That is the correct drawing. We'll put it in brackets and put the charge. Now, you may go, Mr. Day, what if I would have chosen to make that double bond with the oxygen beneath the N? Would it still be correct? Yeah, it would. This Lewis dot structure, sometimes they have multiple abilities to have a double bond in other spots. So you could have had a drawing like this. Could have had a drawing like that. Or if you really wanted to get a little crazy, you could have also had a drawing like this. All of them would have been in brackets with a -1. So for that one particle, there were 3 correct drawings. And we'll get into that a little bit of why and kind of where that we get told about whether we have more than one drawing or not later in our notes and within our worksheet. So let's show kind of what I would expect to see within the column number 4 when it comes to ionic. I don't need to see the transferring of the electrons. I'm looking for the final drawing. So we want to show, I'm going to show it all because I think, at least to begin with, it will help you guys. So we're going to show that. So that step, now we don't need to show. All we need to show is the metal with its charge and the nonmetals with all the electrons and their charges. So you're going to see that the charges on barium and chlorine here could be found on the periodic table. So here's how this is going to work on this slide. These are the first 4 on your worksheet. So we're going to work through them. We're going to work through the first 2 columns, and then I'm going to have you guys practice your drawings and then check back in to see if they're right. So looking at the first one, aluminum is a metal, therefore it is ionic. Carbon is a nonmetal. Bromine is also a nonmetal. The difference is 0.3. 0.3 makes this polar covalent. Se and O are both nonmetals. The difference on that one is 1.1, making it also polar covalent. Phosphorus and oxygen, again, 2 nonmetals. The difference is over 0.3, making it polar covalent. Now we're adding up valence electrons. We just need the numbers. So aluminum has 3. Fluorine has 7 apiece. 7 times 3 is 21, plus 3 is 24. With carbon and bromine, carbon has 4, bromine has 7. 7 times 4 is 28, plus 4 is 32. Se also has 6, so does oxygen. 6 times 4 then, because remember 1 and 3 makes 4, is 24. And finally we have P, which has 5. Each oxygen has 6, so 6 times 2 is 12, plus 5 is 17. Don't forget your negative, making it 18. All right, go ahead and pause it, and then you can come back when you are ready to check your drawings. 3, 2, and 1. Your final drawing here should have aluminum with a +3 charge, surrounded by 3 fluorines with -1 charges. Don't forget to show all the valence electrons around your nonmetals. Moving on to carbon, it's covalently bonded, so what we're going to have is carbon in the middle attached to 4 bromines. Make everybody happy. Count them up. 2, 4, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 28, 30, I'm sorry, 30, 32. Now our last two. So this one had 24. We're going to again put SE in the middle. We're going to attach it. Now, by going through this, I know that if I put this 2 here, make sure everybody has 8, we're going to end up with 26. We'll have 8, 8, 8, and 2, making that 28. So we're going to need a double bond here. Uh, 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So that one was right. And our last one, we're going to put P in the middle. We're going to attach the oxygens. This one I'm going to walk you guys all the way through. We're going to make sure everybody's got 8. We're going to go ahead and count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We have 2 too many, so we're going to erase 2 off the central, 2 off of one of our attached, and we're going to double attach it. We're going to go back and count in 2, 4, 6, 8, 10, 12, 14, 16, 18. That means that we are good. We're going to go ahead and put it in brackets, put the charge, and there we have it. Our first 4 lines on the worksheet were completed together. I want you to go ahead and work on the rest of that worksheet and let me know if you have any questions. Don't forget to leave comments on other people's if you can help when it comes to the discussion board, and hit like and subscribe.